In this video, you're going to learn how to form ionic compounds. Ionic compounds are bonds that are formed between ions, whereas covalent compounds are those that are formed between nonmetals. So today we're going to learn about ionic compounds. In a chemical reaction, atoms tend to either gain, lose, or share electrons to have 8 valence electrons forming. This is the octet rule. If these atoms gain or lose their electrons, then they're typically part of an ionic bond, whereas sharing electrons is your covalent bonding, which we are not talking about in this video. Now, metals will lose electrons and become positive ions, which are cations, whereas nonmetals will typically gain electrons, and in doing so they'll form negative ions. And an ionic bond is always formed between a metal and a nonmetal. What that means is if you have two metals, they're not going to ionic bond together. If you have two nonmetals, they're not going to ionically bond together. But if you have one metal and a nonmetal, they can share an ionic bond. Alright, so let's start out with a metal and a nonmetal example, that of sodium and chlorine, everybody's favorite condiment to put all over their food, table salt. So when sodium and chlorine come together, what happens is sodium wants to give up one electron, and thankfully chlorine wants to accept one. So this lonely little electron here gets to fill the void in chlorine's life. And that doing so, they form an ionic bond. So notice here how sodium no longer has an electron in that third electron shell, whereas chlorine now has a complete octet, but as does sodium, which means they're both stable and both very happy. And here we can write the Lewis structures for the ions that are produced. So let's practice doing this. Let's form these ionic compounds together. Do pull out your periodic table because we are going to need that a whole lot. My first question for you, what ionic compound is formed from the interaction of potassium and chlorine atoms? Now, remember, potassium has one electron. We can find that from our periodic table. Since it's in group 1A, it's going to have one valence electron. Chlorine has 7, which means chlorine wants to gain 1 and become chlorine ions, which are negative, and potassium wants to donate an electron, give one away to become K+, for the potassium cation. And so when they do this, they will react together, and just one will give the other one its electron and form potassium chloride, KCl. That's the compound that is formed. Now it does get a little more complicated than that, but not really. So our first one that we want to look at next is potassium and oxygen. What happens when potassium and oxygen interact? Potassium has one electron to get rid of, whereas oxygen needs 2. So if they react together, oxygen still won't be happy. It needs a second one to really make itself happy. So oxygen needs 2 potassiums, and then it will be content, whereas each potassium only needs to give up 1 electron, and in doing so, it will fulfill their valence electron shell. So once again, if we look at this, our K is going to become K+, and our oxygen is going to be 2-, and we get those electrons, its valence electrons, from what family or group it's in. Alright, so what it looks like in the end is we're going to have 2 potassium atoms react with 2 oxygen atoms to produce 2 potassium ions and 1 oxygen ion. This will have the formula K2O. Notice there are 2 potassiums, and that's why there's a subscript of 2, and there's 1 oxygen. That's why there's no subscript here. Lack of a subscript just means an understood 1. Alright, let's try another one. What ionic compound is formed from the interaction of magnesium and nitrogen? If you'd like, go ahead and stop the video now and give it a try. Alright, so magnesium. We know magnesium has 2 electrons in its outer shell, whereas nitrogen has 5. That means that it needs to interact with 3. Remember, when we're bonding, nitrogen wants to have 3 bonds? Alright, so with those 3 bonds, if it just gives it 2, it's still not happy. And so it could have 1, so it would need 2 magnesiums to make 1 nitrogen happy, but then you'll have an extra magnesium with an extra electron to give away. And so essentially, these 3 electrons here will get donated to this nitrogen, whereas the other 3 will get donated to this nitrogen, making both of them content and very happy. So we end up in the end with 3 magnesiums and 2 nitrogen ions, or Mg3N2. So this is how we form these ionic compounds. Now go read section 4.5, and that'll give you a couple tips too on how to form these ionic compounds.